discussed about the linear PDE, some problems we have discussed, and then I said like we'll jump into quasi-linear PDEs, try to solve. Then I thought like there may be some gaps are missing, so probably I will cover some more linear PDEs with few more problems. Then we'll go to the quasi-linear PDE. Okay. So in this class, once again, we are going to discuss about the linear PDEs only with a few more complicated tasks. Okay, so let us see that. So the first order linear PDEs with constant coefficients we have seen already. So this problem we have solved. So AUX plus BUY equal to 0, which we have solved. Okay, so this problem we have solved already. AUX plus BUY equal to 0, which we have solved. And then so what we did was we tried to find chi equal to chi of x comma y. Transformed coordination we did, and then eta equal to eta of x comma y. And then my aim is to convert that problem into a ODE problem. So that one we have done already. Okay, so this one we have already explained in the method of characteristics. Okay, and then we solve this problem like u of x comma y. So for this problem, the solution was u of x comma y equal to f of bx minus ay. This one we have solved. Okay, now so this is the things which we have already explained: characteristic method of characteristic and characteristic coordinates we have explained. Now let us solve a similar kind of problem with little more complications. So what I'm trying to solve in this one is that we will try to solve this problem: ax plus by equal to plus cu equal to 0. Okay. So in this problem, same thing. I'm going to take the same set of coordinates. So chi equal to ax plus by and eta equal to bx minus ay. Okay, so this problem again, if you transform this problem, what it will come is that it will become like a square plus b square into u chi plus c u equal to 0 is going to come. Okay, so a square plus b square u chi plus c u equal to 0. We have seen that in the earlier one, the same kind of setup we are going to use it here. So in this case, what is the answer is going to come? The answer is going to become like, so you solve this problem. So this problem can be written as u chi plus c by a square plus b square into u equal to 0. We have already assumed that this condition a square plus b square not equal to 0, then only this is going to be valid. Okay, so this condition initially itself we assume. So that's the reason I can divide this. So this is a ODE problem now. Okay, this ODE problem, how do we solve? So in this case, I can solve this one u of chi comma eta. Okay, because it is depending on only now it is become like a function of chi only, it is there because y term is not there. So in this case, it is going to become like e power. So I can solve this problem, very simple problem. Okay, you can just do the separation of variables. So u chi by u equal to, you can push it on the other side. So this is going to become like e power minus c by a square plus b square. Okay, into chi into some constant is going to come. So in that case, some log c we used to put and then we used to put. So same thing it is going to come. So in this case, I'm going to put it some function of eta is going to come. Some constant is to come. Okay, c e power minus c square c, some constant will put it. If you have a problem like dy by dx plus some ky equal to 0, then you will get y equal to some c into e power minus kx will be the answer. Same thing here. Okay, so this problem is same as this one. So in the term of, in the place of c, I'm just putting f of eta. Okay, so in terms of u of x comma y, this is going to become like e power minus c into chi is nothing but ax plus by. So ax plus by divided by a square plus b square into f of eta is bx minus ay. Okay, so this is once again linear PDE with constant coefficients. Okay, so still we are in the constant coefficient. So this one we can do it in the similar way. Okay, now next one I will just extend this idea for one more non-homogeneous PDE or inhomogeneous PDE. So now in this case, what I'm going to keep, I'm just going to keep here instead of cu, I'm going to cu equal to 0. Instead of that, I'm going to put f of x comma y. I'm going to keep it. Okay, f of x comma y. I'm going to keep it. So the same thing, chi equal to ax plus by is there, eta equal to bx minus y is there. Then you transform this in the same way which we did in the last class. Okay, then this is going to become like f of chi comma eta is going to come. This is going to become like f of chi comma eta. So if you transform this equation once again, this is going to become like, in this case, it is going to become like f of some f of chi comma eta is going to come. Okay, u chi divided by a square plus b square. Okay, it is that. Okay, so same problem. I'm just dividing this one. Then what you are going to get? Now you are going to solve this problem. So this problem you are going to solve it in the form. Okay, so I'll erase this. So this problem is similar to what we solved here earlier. So dy by dx plus py equal to q we have solved. Same kind of setup we are going to put it. Okay, so in the you have solved some problems in the exercise where I have given a simple OD, kind of ODE problem. Although it is a PDE, simple only one dependent variable I have used, and then you have solved it. Okay, same thing now what we are having is that suppose you have two variables also, ux and uy is there, still you can transform that problem into a kind of a ODE problem which is depending on only one thing. Then you can solve it in the same setup what you have solved in the exercise problem. Okay, so that's what we are doing. So u chi plus c by a square plus b square f of chi comma eta by a square plus b square. So this is of this form. Therefore, the answer is going to become like u of chi comma eta equal to e power. So this is 1. So minus c by a square plus b square. Okay, into chi, okay, because chi is the variable here, into q. Q is nothing but this one, f of integral f of chi comma eta by a square plus b square. Okay, into e power, again this one, c by a square plus b square. Okay, because this is p is already there. Okay, this is independent of these are all constant only. Okay, so c into e power a square plus b square chi plus into d chi. Okay, plus I used to have some constant used to come. So in this case, it is going to become like some constant will come. So in this case, I'm going to put it as g of eta. Okay, so this is the general solution. So if your problem is of this form, then automatically this is going to be your general setup. Okay, then you can replace that. So in this case, if your f of chi comma eta is known to you, then you can substitute it. Okay, and then integrate this one. Then replace wherever chi is there, replace with the ax plus by and eta in the place bx minus v. So this is the method to solve the problem. Okay, any questions on this one so far? Let us solve one problem. Any questions? Okay, then let us solve a problem. So the problem is minus 2ux minus 2ux plus 4uy plus 5u equal to e power x plus 3. Okay, so let us solve this problem. So I got to solve in this way. So what is chi? First, what is ABC? We will write. So A is minus 2, B is 4, C is u, and F is e power x plus 3y. Okay, what is chi? Chi is ax plus by. So that means 2x plus by, which is 4y. Okay, and eta is bx minus 4y. So 4x plus 2y. Okay, so therefore this is going to become like u chi comma eta is going to become like, okay, this is going to become like e power minus c. C is C is 5. Okay, 5 by a square plus b square. So a square plus b square also will write it. A square plus b square is going to become like 16 plus 4 20. Okay, so minus 5 by 20 into chi integral f of chi comma eta is e power x plus 3y. Sorry, this one I got to find it actually, because I got to write it in f of chi comma eta, right? So this part I have to do it now. So let us do that. So if chi equal to minus 2x plus 3y and eta equal to 4x plus 2y, what is x? X is nothing but you can simplify this. Okay, so you just add these two together. So it is, or I will just multiply with minus 2 here and minus 3 here or plus 3 here, then this is going to become like minus 6y will cancel. So minus 4x plus 4x is going to come. 6x is going to come. So 6x plus, okay, I'm adding it up. So 6x plus 10x is going to become like 10x is going to come. Okay. So 10x. So you are going to get, so chi plus eta here, minus 2 chi plus 3 eta. Okay, minus 2 chi plus 3 eta is this one. So x is going to become like minus 2 chi plus 3 eta by 10. Okay, so you see this one. Okay, so x plus 3y. So you want to find what is x plus 3y. Okay, similarly you can find the 3y. So x plus 3y is going to become like chi plus eta by 2. You can verify that. Okay, so just sum it up. Similarly do the y term and then multiply it. So you are going to get the answer for this. Okay, so chi plus eta by 2 is going to come for the x. So therefore my f is going to become like, so f is nothing but e power x plus 3y. Okay, so that is going to become like e power chi plus eta by 2. Okay, so substitute over here, e power chi plus eta by 2 divided by a square plus b square is 20, and then e power again same thing, e power minus 5 by 20. So here minus 5, here plus 5, 5 by 20. Yeah.
Sir, maybe sir, 16x. Minus
16?
2, 16x, sir.
Which one is 16x?
Sir, minus 2 eta plus first.
Okay, so what so this is the maybe here you just remove that. Okay, so this is going to be check whether this is correct or not. Like x plus 3y equal to chi plus eta by 2, whether it is correct or not, check it. Okay.
Okay.
Okay. So now what you have is that e power chi plus eta by 2, e power 5 by 20 into chi is going to come. Okay, into d chi, okay, plus g of eta is going to come. Now simplify this. Okay, I just leave it to you for verification. So check whether this is correct or not. U of x comma y equal to e power. So I'm just going to the last step, minus 2x minus 4y by 4. G of eta is nothing but this one, 4x plus 2y. Okay, and then plus this term also simplify it and then do the integration, etc. So you go to check that whether it is correct or not. 2x plus 16y by 4 divided by 15. Okay, just check it whether it is correct or not. Okay. Okay, fine. So so this one you can check it. Okay, I'll leave it to you as a verification. Now next one will make the problem little more complicated. Okay, so far we have solved with constant coefficient. Okay, we have solved with constant coefficient. Now what are we going to do is that we are going to simplify it. We are going to make some more complications. So variable coefficients I'm going to use it. So same kind of problem. I'm going to take a of x comma y into ux plus b of x comma y into uy equal to 0. Okay. Now what I'm going to consider is, for this problem I'm going to take a geometric representation of geometric representation of x and y I'm going to take. So I'm going to take a one parameter family, which is nothing but x equal to x of s and y equal to y of s. Okay, which is a parametric family I'm going to take. So means, so if x comma y is there, I'm just going to take x as a function of some s, okay, which is s is a parameter, and y is another function of s, which is a parameter. S is a parameter. Then what I can do is that I'm just going to find the ODE problem. I'm going to write as dx by ds. Okay, so dx by ds I'm going to equate with a of x comma y. Okay, geometric representation of this problem I'm writing. Dy by ds I'm going to write as b of x comma y. Okay, so this part I'm considering. So dx by ds I'm going to denote, I'm going to represent this coefficient, and dy by ds I'm going to represent this coordinate. Okay, then what is the tangent curve it is going to come? It is going to become like dx by ds comma dy by ds, which is equal to a of x comma y, b of x comma y. Almost the same thing what we did it in the characteristic method of characteristics. Same thing we are doing. Okay, in this also. So then what I'm going to write? I'm going to write u of, suppose u is a function of x and y, right? Now u of u I'm writing it as, okay, so x is again function of s and y is a function of s. Okay, so u of x comma y becomes like this. Then this is going to imply I'm going to find what is the total derivative of this one, du by ds. Okay, with respect to s I'm going to find du by ds. I am going to find. So if I want to find the du by ds, this is going to become like ux. Okay, ux, because I got to differentiate with respect to x using the chain rule I'm doing. U with respect to x I'm doing, and then I will be having dx by ds plus I'm having y variable, so uy into dy by ds is going to come. Okay, so but what is what is dx by dx? Dx by ds is a of x comma y. Okay, a of x comma y into dx by ds. Sorry, dx by ds is a of x comma y. So a of x comma y into ux. Dy by dx is b of x comma y. So b of x comma y into uy is going to come, which is nothing but the same this one. Okay, so that means what I can do, this du by ds, how do I write? Again, I can write this as, okay, du by ds can be written this way. Du by ds can be written of this form. Okay, so this one I can write it as del dot, okay, del u dot, del u is nothing but ux comma uy dot dx by ds comma dy by ds. I can write it. Okay, or I can write it as del u dot. Okay, what is dx by ds, dy by dx? This is nothing but a of x comma y plus d of x comma y. This we have did already for that another problem. Same thing we are doing. Okay, so this is nothing but I can write it as dv u. Okay, this is nothing but dv u. Now it is given that a of x comma y into ux plus b of x comma y into uy equal to 0. That means this is going to become 0. That means this is going to become 0. That means this is going to become 0. Okay, dvu equal to 0. Okay, so that means dv equal to 0, where v is nothing but this part I'm just denoting as v. Okay, this is nothing but v is nothing but a of x comma y comma b of x comma y. So that means what I'm going to have, I'm going to have, so this is same as this one, du by ds equal to 0. This is a ODE problem, simple ODE problem. So du by ds equal to 0 means what? U of xy is constant in the direction of v, in the direction of a comma b. Okay, in the direction of v, that is in the direction of a comma b, at x comma y it is going to be du by ds equal to 0. So this is the underlying idea for the next one. Okay, the same thing we are going to use it for the quasi-linear PDE also. So if you are a of x comma y is not equal to 0, suppose a of x comma y is not equal to 0 in this case, then what I can do, the same problem, okay, this problem I can write it as dy by dx. What is dy by dx? Dy by dx is nothing but dy by ds into ds by dx. Okay, dy by dx can be written as dy by ds into ds by dx. So that means what is dy by ds? Dy by dx is p of x comma y. Okay, and ds by dx is 1 by ax comma y. So that means ax comma y. So if a of x comma y is not equal to 0, if this term is not equal to 0, then I can write dy by dx equal to a of x, b of x comma y by a of x comma y. So this is called the characteristic equation for this equation. Okay, for this equation, this is the characteristic equation. Okay, so if I obtain the solution for this problem, this is the for this one. If I obtain the solution for this one, that is called the characteristic curve for the problem, because we are going to get a curve for this one, right? If we solve this dy by dx equal to b of x comma y by a of x comma y, we are going to get a curve. So that is called characteristic curve, and this method is called method of characteristic. So our idea is that you need to find what is your x of x, x equal to x of x, and y equal to y of x. If you are solving that, then you can find this. So for that also some easy method is there. Let us see that how to do that. Okay, so same thing. Now suppose I'll make little more complicated. Suppose I have c of x comma y plus c of x comma y into u equal to f of x comma y is there. So in this case, what is going to come? Okay, in this case, what is going to come? Same kind of thing. Okay, use x equal to x of x, y equal to y of x, dx by dx equal to a of x comma y, dy by dx equal to p of x comma y is going to come. Again, same thing. This is the derivative. So ux comma s you can take it. So du by dx equal to ux dx by ds, uy by dy by dx, etc. is going to come. Okay, this is going to come. Then now this problem, what I'm going to do, okay, So for this problem let us reconvert. This problem let us reconvert. Okay. So if this is going to satisfy, okay, if this a of x comma y plus ux plus b of x comma y uy is satisfying this one, then what I can do, okay, so in this portion, only this portion, I can replace with whatever here. Okay, so therefore this is going to become like du by ds. So whatever I have boxed here, that is going to become like du by ds plus I'm going to have c of x of s comma y of s into u equal to f of x of s comma y of s is going to come. Okay. So next one, we can solve this problem now. Okay. So this equation, okay, this equation is called the characteristic equations. Okay, this is called the characteristic equations or characteristic system of 7. Okay, this equation is called the characteristic system of 7. Okay, so 6 and 8. So these two are called characteristic system. dy by dx equal to bx comma y means you are solving the homogeneous part and non-homogeneous part. You can separately solve it. So that is called the characteristic equations or characteristic system of the equation. So again, if you solve this problem, okay, you solve this problem and then obtain the values, then that is called the characteristic curve. And again, this is called method of characteristics. Now, suppose c equal to 0 here. Suppose c is 0 here. Okay. Suppose c is 0. That means this is going to become like du by ds equal to f of x of s comma y of s is going to come. Okay. So therefore, what is du by dx is going to come in this case. Du by ds is going to become like, okay, so in this case, and du by dx is going to become like, I have to find what is my du by d. So in this case, du by ds into ds by dx you have to find. Okay, du by ds is this one. So f of x of s comma y of s, and ds by dx is this one, which is nothing but a of x of s comma y of s. Okay, so this is called du by dx. Okay. So this condition is called compatibility condition. The name of this condition is called compatibility condition. Okay, this is called compatibility condition. Okay, so how do we solve this problem? Suppose, okay, so let us forget about c equal to 0. How do we solve this problem? Okay, how to solve this problem? Du by ds equal du by ds plus cu equal to f. Okay, how do we solve that problem? So again, same thing. So you know that this can be written as, this problem I can write as du by ds plus c of s into u equal to f of s. I can write it because everything is a function of s. So this is going to become. Now this is a ODE problem with respect to the variable s. Now you can solve this problem. So this problem you can solve it. How do you solve this? This u of s equal to, you can solve it as e power minus integral c of s into ds. Okay, and then you can put some constants. Okay, the constant you can put it c plus some integral then f of s into e power c of s, okay, ds into ds, you can put it. So this is going to be your u of s, you can solve it. Okay, u of s you can solve it. Now suppose c of s naught is given to you, then what you can find? You can find the solution of u along the entire characteristic curve. You can completely determine. Okay, so suppose some curve we are giving. Okay, some curve if I'm giving. Okay, suppose I have a I'm giving a curve. Gamma is a curve given. Okay, which is passing through all the initial points of this integral surface. This is the integral surface. Okay, then this is called the initial curve on the integral surface. Then it is called the initial curve on the integral surface. Okay, so suppose some point I have given where this is going to pass through all these points. Okay, all the points of the integral surface, passing through all the initial points of the integral surface. Then it is called initial curve. So for example, I'm just giving a remark on this one. So this is my problem, right? X equal to x of s, y equal to y of s. Suppose I'm giving the initial condition. Okay, whatever I explained in the last one, I'm just repeating it. Suppose I have given x equal to x of s naught and y equal to y of s naught. Sorry. So x of s naught equal to I'm giving some curve. Okay, x of s naught equal to x naught of s I'm giving, and y of s naught equal to y naught of s, some curve I'm giving. Okay, some curve I'm giving. and another condition u of s not equal to u naught of s I have given. Okay, this is I have given. That means what is this one? This I can write as, or I can write as this is nothing but u of x naught of s, comma y naught of s. Okay, which I have given for some s in some interval. Okay, then what is it going to do? This is going to fix all the points on gamma. Gamma is some curve. Okay, through which a unique characteristic curve is passing through. So if I fix this one, some gamma is an initial curve, okay, which is given by this one. This is nothing but my gamma. Okay, if it is given, this is nothing but my gamma. Then for every value of, so here s belongs to I. For every value of s in I, okay, it fixes a point in this curve. Okay, it is going to fix a point in this curve, gamma, through which there will be a unique characteristic curve passes. So this one we are going to prove it using the quasi-linear PDE. I'm not. This is the idea behind that. Okay, so for this we need a inverse mapping theorem, which we are going to prove it anyhow. Okay, so let us see that once we are solving that inverse mapping theorem related to that existence uniqueness theorem. So this is the underlying idea. So if I just have a characteristic equation and characteristic curve is there, and you have given an initial curve, what it is going to do is that you can define an initial curve like this: x of s naught, y of s naught, and u of s naught. For this, you can find the function such that x naught of s, y naught of s, where s belongs to I, and for every value of s in x in I, it fixes a point in this gamma, and that should pass through this. That should determine the unique characteristic curve. Okay, so that's what we will prove it. Okay, now one more thing. Okay, now as I mentioned, so here we have some method to solve this. Okay, but sometimes it may not be easy to solve this problem. So in order to solve that problem, we will transform the problem into again the canonical form. The canonical form means we'll transform it into the characteristic coordinate system, and then we'll solve. Okay, let us see that how to do that. Any questions so far? Any questions? Okay, if not, I will continue. So now let us take the same problem: a of x comma y into ux plus b of x comma y into uy equal to 0. Okay, now what we are trying to do is that in the earlier case we used to something, right? Suppose aux plus buy, it's with the constant coefficients. Okay, what we did was we took eta equal to ax plus by, and chi equal to ax plus by, and eta equal to bx minus ay we have taken, right? Same thing we are going to do now, but not this one. I'm not going to do this one because it is no longer a constant one. So in this case, what I'm going to assume that I'm going to assume some change of coordinates. So chi equal to chi of x comma y is going to be there, and eta equal to eta of x comma y is going to be there. So some change of coordinate I have obtained. Okay, so then in that case, what is going to become? Same thing what we did in the earlier one. So ux is going to become like u chi x plus u eta x, and uy is going to become like u chi y plus u eta y is going to come. Okay, so I can use this one over here. Okay, if I use this one, this is going to become like a of, so u chi x plus u eta x into a of x comma y. Okay, so simply I'll put a here because here a means I'm just going to assume that it is a of x comma y. Okay, plus b into so I'll put it here, a into plus b into this one u chi y plus u eta y equal to 0. Okay, now I simplify this one. So what I'm going to do is that I'm going to take u chi as a common. Okay, then this is going to become like a chi x plus b u chi I have to take, so b chi y into u chi plus u eta I have to take, so this is going to become like u eta plus b u eta x. Okay, u eta x plus b eta y into u eta equal to 0. Okay, so that's what I have written in the last step. A chi x plus b eta y u chi plus a eta x plus b eta y in u eta equal to 0. Okay, so still, see, in this problem, actually, we try to solve that, and automatically one of the things with a square plus b square equal to 0, it automatically, once we transform this one, it automatically become like u chi equal to 0, it become. But in this case, it is not happening because I don't have that conditions over here to satisfy that one. So in this case, I'm not getting that required results. So what we are going to do is that our aim is to convert into a OD. That means I need to make either u chi equal to either the coefficient of u chi should be 0 or the coefficient of u eta should be 0. So in that case, this will become like a ODE problem, and my problem will be very simple, and then I can solve it. But it is not going to happen. It is not happening here, okay? Because I am not still. It is in the earlier it was the ODE PDE in x comma y variable. Now it is again a PDE with variables chi comma eta. Okay, it's again a PDE with chi comma eta. Means I'm not removing any of the variables. Any of the coefficients are not going down. So that means again I'm going to get into the trouble. So it will be a loop. So in this case, what our aim is that I have to make in such a way that one of the coefficient is going to become 0. Okay, one of the coefficient is going to become 0. So in this case, what I'm going to assume is that I'm going to assume a eta x plus b eta y equal to 0. I'm going to assume. Okay. Yeah. So in this case, what I'm going to do is that a eta x plus b eta y equal to 0. I'm going to take. So without loss of generality, what I'm going to take, I'm going to take a not equal to 0. So this also I'm going to take it. Okay. Locally, it is not equal to 0. So therefore, this is going to become like eta x plus b by a into eta y equal to 0 is going to come. Okay. So that means what I'm going to have. Okay. So for so I can simplify this. This is going to become like, so this one d what is eta y? Eta y means eta y is nothing but d eta by dy. Okay. What is eta x? Eta x is nothing but d eta by dx. So that means what is dy by dx? Dy by dx I can write as dy by dy by d eta into d eta by dx. I can write it. Okay. So that means this one I can write it as what is dy d eta by dy. So this one I can write as, okay. So dy by d eta means this is nothing but eta x divided by eta y. Okay, eta x divided by eta y. So that is nothing but, so eta x divided by eta y is going to become like minus, I can write as so eta y, this is going to be here and this is going to be here. So eta y by, so I can write as minus b by e. Okay, minus b by e. Okay, so I'm going to take that. Now what I'm going to do, eta x plus beta by, so d eta, now what is this one? D by dx of, so this is d by dx, d by dx of, okay, I'm going to find it. What is eta of x comma y of x? I'm going to find it. Okay, so this is going to become like, so if I find this one, this is nothing but eta x, okay, because eta is a function of x and y, plus I'm going to have eta y. Okay, so I'm going to take eta y into dy by dx. Okay, so I'll just explain it in another term. Now what I am going to do is that, okay, I'm going to consider forget about this one. What I'm going to consider is that I'm going to consider slope of the curve with this coefficient dy by dx. I'm going to consider. So I need to, what I need to find is that I need to solve this problem. In order to solve this problem, I am assuming a eta x plus b eta y equal to 0. I'm going to assume with a not equal to 0. I'm going to take. Now there is a this equation I have obtained. Okay, eta x plus beta by a into eta y I have obtained. Now what I'm going to consider is that I'm going to consider a curve whose slope is this term. Okay, I'm going to consider a curve whose slope is b by e. Means dy by dx equal to p by a. I'm going to take. Okay, this condition I'm going to take. So dy by dx equal to p by a slope. I'm going to take it. Then this condition d by dx of eta of x comma y of x I'm going to define. Okay, because this eta is a function of x comma y. So eta of x comma y of x I'm going to find it. That is going to become like eta x eta y into this dy by dx, I'm going to take this curve which is having a slope b by a. So that is going to become this one. That is going to become 0. So that means what is it going to come? This d by dx of eta x comma y comma x is going to become 0. Okay, that means this is automatically what is it going to represent? Okay, this is going to represent this is going to represent the characteristic curve for me. So if I satisfy this one, then this is going to be my characteristic curve. Okay, and that is going to imply that d by dx of eta of x comma y of x equal to 0. This is going to imply eta of x comma y equal to some constant. I repeat again. This condition, this problem I got to solve. In order to solve this problem, I reduced to canonical form, but the canonical form still it is having chi and eta as the variables. Okay, chi and eta terms are not vanishing. Okay, so means I'm not able to find the conditions like this. Okay, this is not happening. So in this case, what I'm going to do is that at least one of the things I have to assume 0. So either I got to assume this is 0 or this is 0, then the problem is solved. So if I want to do that one, I got to check. I cannot assume it randomly. I got to check whether it is going to make sense or not. So for example, I'm going to take this curve. So in this case, I'm going to take a eta x plus b eta y. I'm going to take it as 0. Then okay, so a not equal to 0. This is whether it is making sense or not. For this, I got to define something. Okay, when it is going to make sense, also I got to define. So a not equal to 0, then this is going to become like eta x equal to beta by b by a into eta y is equal to 0 is there. Now I'm going to define a curve, characteristic curve. I'm going to take. I'm going to take characteristic curve which is satisfying this condition. dy by dx equal to b by a. Only those curves I'm going to take it. So if those curves are taken, then automatically I can find what is my d eta by dx. So d eta by dx is going to become like eta x plus eta y into b by a is going to come because I'm taking a characteristic curve of this form. So that is going to be satisfied. Okay, because this is going to become like eta y into dy by dx will come. So dy by dx is b by a. So this is 0, which we have already assumed. Okay, so this is going to 0 means I'm going to have only eta of x comma y equal to c is going to come. So when this is going to be coming, eta of x comma y equal to c only for this kind of characteristic curve. When the characteristic curves are satisfying this condition, dy by dx equal to a b by a, then this is going to become like eta of x comma y equal to c is going to come. Okay, so this is true when when eta of y not equal to 0. Okay, eta of y should be not equal to 0. Okay, so so what we did was, now we found a new variable. Okay, new variable for so you got to find a variable eta. Okay, new variable eta for which this PDE becomes OD. Okay, so you got to find eta which is satisfying these conditions, these conditions, these conditions. Okay, so you got to find the eta in such a way that this one should be satisfied. You got to find the eta new variable in such a way that this is going to be satisfied. So in that case, this will automatically reduce to OD. So very simple one. There may be plenty of things. Okay, very simple one. I'm going to select is that I'm going to select. Okay, I'm going to select. Let me see. Eta of x comma y equal to x. Maybe some mistake. Let me see. Eta of x comma y equal to x. Done. Okay, fine. Yeah, so this is one thing. You got to select here eta of x comma y equal to some constant you got to select. Okay, and then you got to select when eta of y not equal to 0, this is going to be there. Now what we need to select is that you need to select the this one. So these two you got to select it. Okay, these two you got to find it. So in such a way that these conditions are satisfied. Now what I'm going to select is that I'm going to select eta of x comma chi of x comma y equal to x. I'm going to select it. Okay, then what is it going to happen? Let us see. Okay, what will happen? Let us see. Okay, so what is the Jacobian? We got to find it. Okay, in such a way that this is going to happen. So suppose I got to choose in such a way that I will tell you, because this is the important thing for the inverse mapping theorem. So this part is clear, I hope. If it is not clear, let me know. Now what we need to do is that we have x comma y is there and chi comma eta is there. Okay, So now we got to find a transformation in such a way that your Jacobian, okay, Jacobian is not equal to 0, that you got to choose it. You got to choose your x comma y to chi comma eta in such a way that Jacobian is not equal to 0. What is Jacobian? Jacobian is nothing but determinant of dou chi by dou eta. Okay, so or I can write it as this way and then we'll write it. So this is nothing but dou chi comma eta divided by dou x comma y. So what is this one? This is nothing but determinant of dou chi by dou x, dou eta by dou x, dou chi by dou y, and dou eta by dou y. Okay. Or you can write it in the other way because the determinant is not going to change. So this is going to become like dou chi by dou x, okay, into dou eta by dou y minus dou eta by dou x into dou chi by dou y. Okay, so this is going to become like, since I have chosen a chi of x comma y equal to x, this is going to become like dou eta by dou y. Okay, and this is dou chi by dou y, it is independent of x, so it is going to become like 0. Okay, minus 0. So that means what I'm having, eta y is there. So if I choose my eta y not equal to 0, suppose I choose my eta y not equal to 0, then what I'm going to have, okay, if eta y is not equal to 0, then what I'm going to have is that I'm going to have something in such a way that this this transformation is going to be unique, and then you are going to solve the problem also in such a way that this is going to become like 0. Okay, so let us see that how it is becoming. The next one. Any questions on this one? How do we select? Okay, so if you choose in such a way that this is going to happen, then what is it going to come? This is going to become like a of chi comma x, b of x comma y, chi comma y is there, right? So chi of x comma y I got selected as x. Okay, so therefore this is going to become like a. Okay, chi x is 1. Okay, this is 1. B into chi y. There is no y term, so that is going to become like 0. So therefore this is going to become like a u chi is going to come. Then this one I have already selected eta of x comma y equal to c. Therefore this is going to become like completely 0. Okay, this is going to be completely 0. So therefore this is going to become like 0. So therefore what you are going to get, u chi equal to 0 is going to come, which is going to give you u is equal to f of eta. Okay. So this equation is called canonical form of the equation a of x comma a of x comma y comma ux comma b of x comma y. Any questions? Any questions? So again I repeat, okay, so this is the problem given, a of x comma y comma u of x comma b of x comma y ui equal to 0. As we did it in the constant coefficient, I got to find eta and chi. Here it was easy because we know what is that in the setup, in the characteristic coordinates, we know how to write that straight line, and using the perpendicular concept in the geometry concept, we found this chi and eta. But in general setup, it is not known because a of x comma y and b of x y can become some curve or some surface, so we don't know what is that. So in this case, you got to randomly you got to assume like chi and eta is going to be some function. Then you transform this problem, but again you end up with something like another PDE only, not ODE. So in order to make it ODE, either you make it this as a 0 or make this as 0. Okay, so in both cases you will be getting a same unique answer only you are going to get. So either make this one as 0 or make this one as 0. Okay, so if I'm just assuming this one is 0. Okay, this is going to make, I'm just going to make it as 0. So in order to make it as 0, I need to verify some of the conditions. So one such condition is that I got to check what is the characteristic curve. Okay, the characteristic curve where this eta of x comma y is going to become like some constant one, and the Jacobian should satisfy this condition. Okay, so Jacobian should satisfy this condition. So if this is going to satisfy, then automatically a u chi equal to 0 is going to come. Then you are going to get this answer. Okay, now let us make it complicated a little more. So instead of this one, I'm going to solve this problem. Okay,
sir.
Yeah,
Sir, why we can't select eta and chi ax plus by like in the previous case?
You can't because in that case these are all constants. Here what is a? It is not ax plus by. This is a of x comma y, right? These are all constant here. Therefore, you can write it ax plus by because we know that characteristic curve exactly, and then we can find it. Here we don't know what is the characteristic curve at all. Okay, so therefore you cannot select this one. Only for constant coefficient you can select it. Here you don't know what is the a of x comma y and b of x comma y. Randomly some curves will be given. I can put some e power xy or sin xy. I can put it, and then you can't find it in this way. This is here it is constant. Therefore you can put it. Okay, you can find exactly the characteristic lines are going to come. Here you are going to get characteristic curves only. Okay, that curve you cannot determine easily.
Yes.
Okay, so again this problem, let us make it a little more complicated. So let us add c of x comma y and f of x comma y. So in this problem, once again a similar kind of setup is going to come. You do the same job whatever you did it over here. So in this case, this is going to become like a u chi, okay, plus c u equal to f of f is going to come. That means this is nothing but a of chi comma eta u chi plus c of chi comma eta into u, okay, equal to f of chi comma eta is going to be there. Okay, so that means again this is the ODE problem because only chi is the variable here. Okay, remaining things are some functions only. So that one you can just solve it as you did it in the exercise problems. So in this case, what is the answer is going to come? So you can find the integrating factor. So the integrating factor you can find for this one. That is going to find. This is not straightforward again. Okay, you got to find u of chi comma eta. You got to find it. Okay, integrating factor you got to find it. So that is nothing but e power. Once you find the integrating factor, you will get it like nu of chi comma eta equal to this going to become c of chi comma eta divided by a of chi comma eta is going to come. This you might have studied in the ODE course. Okay, the same thing. Integrating factor you got to find it. Then you can solve this problem. Okay, this is going to be the integrating factor. Then u of chi comma eta you can find it. That is going to become like 1 by mu into chi comma eta. Then one integral mu of chi comma eta into f of chi comma eta divided by a of chi comma eta into d chi plus some initial conditions. If it is given, you can put u naught of chi comma eta or some functions you can put. Okay, whatever is given. So this is the first order linear PDE with constant function. So let us solve one problem. Okay, so what is the general solution of this PDE? See, the one condition here I have assumed is that this one, okay, this chi equal to x I have assumed, right? It is not necessary that you got to assume chi of x comma y equal to x should be assigned. Okay, this is one choice I have given in such a way that this Jacobian is not going to become 0. But it is not necessary that you have to get the same thing. You can select any of the curves which is going to satisfy this Jacobian is not equal to 0. And you can verify that this is going to give the same kind of solutions only. So that what will prove it once we prove the existence and uniqueness theorem. So in that case, you are going to get the same curve. Okay, same thing you are going to get. Either you choose chi of x comma y equal to x or chi of x comma y equal to x square, whatever you choose it, you should get the same kind of things. Okay, so ux plus yuy equal to 0. Let us solve this problem. Okay, so the characteristic curve, what is the characteristic curve? Dy by dx equal to b by a is the characteristic curve. Okay, what is b here? B is nothing but y, a is nothing but 1. So dy by dx equal to y by 1 is the characteristic curve. Okay, so that means what I'm going to have, y equal to c e power x is going to come. Y is going to become like dy by y. So c e power x is going to come. C is some constant. So I can choose my chi equal to x. I can choose it. Okay, and eta equal to, so we have eta of x comma y equal to c I have chosen. Eta of x comma y equal to c I have chosen. Therefore, this is nothing but what I'm going to have. I'm going to have c is nothing but y equal to c e power x. Therefore, c is nothing but y e power minus x. That is nothing but my chi of x comma y. Sorry, eta of x comma y. So chi equal to x and eta of x comma y. So this is my thing. Chi equal to x and eta of x comma y equal to y e power minus x. Okay. Therefore, what is the solution is going to come for this one? U of chi comma eta is going to become like f of eta is going to come. Okay. So that means u of x comma y u of x comma y is going to become like f of what is chi? Chi is nothing but y e power minus x. Okay, so this is the simple problem. Same way, one more problem. So xux minus yuy plus y square u equal to y square. Okay, so in this case, what we need to do, same thing. So dy by dx equal to minus y by x is going to come. Okay, so therefore you are going to integrate this one. So this is going to become like dy by dx, and dx by x is going to come. So you are going to get xy equal to c, hyperbola you are going to get xy equal to c is going to come. Okay, so eta equal to x and c equal to xy. So therefore I can write it as eta equal to x and chi equal to x and eta equal to xy. Okay, so that means I can write other way. I can write x equal to chi also there, and y equal to eta by x is there. Okay, so these are all two variables. Or this is x, so this is going to become like chi. Okay, so this is the one transformation from chi to x. This is x. This is x to chi. Okay, this is chi to chi comma eta comma. So this is nothing but chi comma eta in terms of x comma y. Okay, this is in terms of this is x comma y in terms of chi comma eta. Okay, so now what I need to do, I need to find what is my a of chi comma eta. Because why do you need to find? Because in order to solve this problem in the canonical PDE, you got to solve it in you got to get it in terms of chi comma eta first. Okay, then at the end you can replace with chi and eta. So therefore a of chi comma eta is a of x comma y is x. Okay, so therefore a of chi comma eta is going to become like, what is x? X is chi. Okay, and what is b of x comma y? B of x comma y is minus y. Therefore b of chi comma eta is going to become like minus y, so minus eta by chi. Okay, and then c of x comma y is nothing but y square. Okay, so therefore c of chi comma eta is going to become like y square. Y square is eta square by chi square. Okay, that I have. Then f is also there. Okay, f is also y square, so that is also same. Okay, this is also same. F of chi comma eta is also same. Okay, now what I need to find? I got to find my integrating factor. Okay, so I got to find my integrating factor. I will erase this. So I got to find the integrating factor. The integrating factor is mu of chi comma eta, which is nothing but e power integral a of chi comma eta divided by c of chi comma eta divided by a of chi comma eta. So c of chi comma eta is eta square by chi square. Okay, and divided by a of chi comma eta. So that is going to become like again chi. So you are going to get it. Okay, so you are going to get eta square. Yeah. Okay, so this is going to become like chi, another chi. Okay, by divided by, so it is going to become like this one. So therefore, what you are going to get d chi. Okay, d chi you have to do. Is it minus or plus? Let me see. Mu 1 by mu. Some mistake is there. C is fine. C is this one. C is fine. I think it should be plus, right? Eta square by P is this one. So eta square by chi square. It should be plus, I think. Okay, just verify that. Okay, so it should be plus, I think. Eta square by chi square and chi cube is going to be there. So then integrate and then check whether what is your mu of chi comma eta. Okay, then you obtain that. So what is this one? Verify that. Okay, then obtain that u of chi comma eta. Then you apply this one 1 by mu into chi comma eta. Okay, and then integrate that. Okay, with the e power etc. and then integrate it. Okay, the another integral and then put it etc. Okay, so verify that whether it is correct or not. If any mistakes are there, let me know. Okay. Okay, I think it is time now. Yeah, so this part I have already covered. First order quasi-linear PDE. I will just repeat this because you know like how to get this one. Now you will get more clarity of how it is working in the quasi linear PDE. So which I will explain in the Monday class. Okay. So this one we have already seen, but in order to understand the existence and the uniqueness theorem, I will repeat it again in the next class and then we'll see it. Any questions? Any questions? Just verify whether the examples which I have written is correct or not. Okay, so there may be some plus or minus mistakes may be there. Just check it. Okay. Kritik Singh, are you there? Kritik Singh, what happened to this guy? Okay. Yeah, that's all. Any doubts you can ask me. Otherwise, done. Thank you. Any questions?
Sir, when you are doing that Jacobian and we are taking that Jacobian will not be zero. My question is that if